criteria for deciding what type of test is being performed is in this guide here. It tells you how you can know if you have a left tail, right tail, or two-tailed test. Either HO or HA can be used to decide what type of test it is. In this page, we're going to use a different method for deciding whether we should reject or fail to reject the null. First, let's set it up like we had done in the past to compare the two methods. The alpha of this test is 0.02, and it's a left-tailed test. So I'm going to start off by drawing the boundary between the rejection region and the fail to reject region. Okay, although we know the area in the tail is 0.02, we need to know what critical value that corresponds to. So let's go back to the tables, see what we can discover. We have a left-tailed test. If you look at the one-tail row, you'll see that the 0.02 is actually not on the list, and sometimes that happens. So with that in mind, we should go to the Z table now and just look up an area of 0.02. Right here and here, these ones are both close. The one on the right, though, is closer. So let's use that one, negative 2.05. That will serve as our ZC. Now we see that our standardized test statistic here, our standardized test statistic is negative 2.23. Is it in the rejection region or not? Yes, it is left of the cutoff, so it's over here. Since Z star is in the rejection region, reject HO. But we haven't used the p-value yet. So what is the p-value? It's a different way of deciding whether to reject or fail to reject. The p-value is going to be the area in the tail of the standardized test statistic. Okay, so let's find the p-value. To do it, we should go back to the tables and look up a z of negative 2.23, because that's the place where the star is. So let's go ahead and look up the p-value in the tables. We need to find the z-score of negative 2.23. We need to find the z-score of negative 2.23 and get the corresponding area. Here it is, 0.0129. So our p-value is 0.0129. We can now make our decision about the test using the p-value and comparing it to alpha. So if p is less than or equal to alpha, then we'll reject HO. If p is greater than alpha, we'll fail to reject. In our case, since p is less than alpha, we'll reject HO. And that should make sense from a geometrical standpoint. The area of the red is less than the area of the blue, and that implies that the standardized test statistic must be within the rejection region.